Section 2 goes one little step further. Now we know what an inequality is. We know how to write an inequality. We know what those symbols mean. We know how to graph the solution to an inequality. So now we're going to start working with inequalities, and we're going to start doing that by using addition and subtraction. I will just tell you right off the bat that these sections are very, very similar to your previous chapter, solving equations with addition and subtraction. You already know how to do that, theoretically, right? So you should know how to do this fairly easily as well, because they kind of are the same thing. First, we just want to define equivalent inequalities. These are just very simply inequalities that have the same solution. Inequalities that have the same solution. I'm actually going to put an S on the end of that, the same solutions. Because we don't have just one solution in inequalities, we have an infinite number of solutions in inequalities. So I need to put an S on the end of that. So if we take a look at that definition and compare it to the definition for equivalent equations, which, by the way, if you don't remember the definition for equivalent equations from the last chapter, it was equations that have the same solution. How are these two definitions the same? They both have the same solution. Yeah, they have something in common, okay? In equations, it's the same solution. In inequalities, it's the same solutions. How are they different? One has one solution, the other has many solutions. Also, the word equation and inequalities would be a little bit different. One, you're working with an equal sign, the other, you're working with inequality symbols. But to answer this question, compare the above definition, how are they the same? They both share solutions. All right, so we just dive right in. To solve inequalities, to solve inequalities, you can use the ideas that we got from the properties of equality. And what we do is we call those the properties of inequality. That's what we're going to be using to solve these inequalities. And they are almost entirely the same as the properties of equality. So, solve and graph each solution. X minus 15 is greater than negative 12. If this was x minus 15 instead of the greater than is equal to, don't scribble that out, I just want to show you this. If that was the case, then what would we do? We'd add 15 to both sides. We're going to do exactly the same thing with inequalities. So let me get rid of that. And instead I'm going to add 15 to both sides with my inequality. It works exactly the same. What I do to one side, I have to do to the other. So that gives me just x on the left. Negative 15 plus 15 is 0, so it disappears. The inequality symbol, the greater than symbol, comes down. And then I have negative 12 plus 15, which is positive 3. So in order for the original inequality to be true, I have to substitute in any value that is greater than 3, is what that says. X is greater than 3. And now we need to remember how to graph the solution, because it says solve and graph each solution. To graph it, we need to draw a number line. We need to put the number directly in the center. That's a 3. We need to put a couple of numbers on either side. So we have maybe 4 and 2. Now we have a nice complete number line. Again, in the back of the book, you'll see lots and lots of numbers. That's okay. I need to remember to put a dot on the number line at my number, which is 3. So what kind of dot will I put? This is an open dot because it just says greater than. So open dot, And then I go up, and I go which way? To the right, because that says greater than, and the numbers that are greater than 3 are like 4, 5, 6. So that's an arrow to the right. All right, I'm also going to go a little bit ahead in the book here, and I'm going to introduce a way to write your answers. It's called set builder notation. Your answers can be written very formally. This is sort of an informal version of an answer for an inequality. Kind of like on hat day, we're very informal today, right? Like I'm wearing jeans, I got a hat on. Maybe I want to be like a kid and kind of wear it kind of like dopey. No, I don't want to do that. This is very informal. But if we were being very formal, that'd be like prom day, right? Like I'd be wearing a tuxedo, I might have actually shaved for once, right? You guys would be wearing nice looking dresses and nice looking tuxedos and everybody would be looking really nice. That's very formal, okay? The same thing is true here. We have a very informal hat day, nobody cares about anything type of day where everybody's wearing their scrub clothes. We have a very formal set builder notation for prom day, and we need to write our answers like prom day using set builder notation. So what we're going to do is we're going to write squiggly bracket. Yeah, get to write a lot of squiggly brackets in this now. Then we're going to write our variable, which in this case is x. And then we're going to draw like a vertical bar. That little vertical bar there is called such that. And you'll see what I mean in a second. When you read that, you say such that. And then you just write your answer. X is greater than 3. And then you close your squiggly bracket. That's a very formal, very mathematical way of writing that answer. And you read it like this. In the informal way, you just say x is greater than 3. But in the very formal way, you say x values such that x is greater than 3. So when you write this, try to write it down while you're saying x such that, and then x is greater than 3. Okay? So x values such that x is greater than 3. That's it. That's the very formal notation. This is the same answer as this, just like you are the same person as you were on hat day when you're wearing a very formal dress or tuxedo. Okay? But this is the language of mathematics right here. It's no big deal. All right, second one. Let's see if we can write our answer informally and formally and graph it. So we're using set builder notation and graphing. N minus 5 is less than negative 3. What do I need to do to solve for n? Add 5 to both sides. That's right. So plus 5 here, plus 5 here. And I get n is less than 2. All right? Let's put that in set builder notation now. So I'm going to write squiggly bracket, n values, the bar says such that, and then I just write my answer again. N is less than 2. Close your squiggly bracket. Now I just need to graph it. Draw my number line. Dead center goes 2. And then give me a couple numbers for, okay, 3 on the right side and 1 on the left side. And now what? We need a dot for sure. This says just less than, not less than or equal to, so this is an open dot. Again, if you don't put the dot on there, it will be wrong. So make sure you include your dots. And which way? To the left. Less than is like 1 is less than 2, so that's why I'm going that way. Okay? So technically, I guess you have 3 answers that you have to give me here. The answer, and then the set builder answer, and then the graph. All right, I want to talk about this last one here because it's tricky. We had a tricky problem in the last section. This one's tricky as well. So I want to solve for x first. What do? We are going to add 9 to both sides. and on the left I get 21, is greater than x. Is there a problem here? X is on the wrong side, yeah. So in an equation, it doesn't matter what side x is on, because you have 3 equals x or x equals 3. They're both the same thing. But you can not just reverse this without also thinking about that inequality symbol. So this says 21 is greater than x, which means if I read this backwards, x has to be less than 21. So if I were you, what I would do is I would rewrite this as x is less than 21. Okay? That's just reading backwards. I'm going that way from my answer. You guys all see that? How that works? That's probably the hardest part about this whole chapter is when those are written backwards. So now that I did that, I can write this in set builder notation. So I'll write what? Squiggly bracket. By the way, that's a brace, but I like calling it squiggly bracket. It's more fun. My variable x such that x is less than 21. Squiggly bracket. Okay, so that would be the set builder notation solution. And then we got to draw our graph. We put our 21 dead center, and maybe 20 here, and maybe 22 here. Maybe you put 0 and 40. It doesn't really matter. I need a dot, which is going to be open. And I need to go, it says x is less than, so I got to go that way. Okay? Notice that if you were to use this solution right here, 21 is greater than x, it might make you think you need to go this way with that arrow. That's why with inequalities it's so important to write this in the correct way so that when you try to draw that graph you get that arrow going the right way, the correct way. Okay? Go ahead and try the bottom 3. I want to see the solution like this. I want to see the set builder notation, and I want to see a correct graph. Go ahead. So for the first one, what do I do? Subtract 6 from both sides. And I get y is greater than negative 10. Let me show you a little trick here. My solution is y is greater than negative 10. I want to write that in set builder notation. Watch this. There's your answer. Okay? So you're able to do that if you don't have to rewrite the answer. You just put it in set builder notation just like that. And now you can draw your graph. We have negative 10, and then maybe negative 9 on the right, and negative 11 on the left. The dot will be open, and greater than is to the right. Next one, what do we do? Got to subtract 12 from both sides, good. And that gives me negative 13 is greater than or equal to y. But that's in the wrong order, so I got to read this backwards. If it says negative 13 is greater than or equal to y, then if I read it backwards, it says y is less than or equal to negative 13. So then I just write that down. Y is less than or equal to negative 13. And now that that's in the right order, I'm just going to build the set builder notation around it, such that the y, the squiggly bracket, the squiggly bracket. And now it says y values such that y is less than or equal to negative 13. So that's the good answer right there. Draw my number line. The negative 13 goes right here. Negative 12 goes to the right. And then negative 14 here. The dot is closed this time because it's or equal to. And then less than is to the left. And finally, what do we do here? Subtract 3 from both sides and we get we get 4 here, is less than or equal to x. That's in the wrong order again, so we read it backwards. X is greater than or equal to 4. So that's what we write, and then we just build the set builder notation around that. We draw our number line. 4, 5 here, 3 here is fine. dot is closed, and greater than is to the right. There you go. Okay, so no big deal. The directions in the homework won't ask you for set builder notation. Feel free to put it in set builder notation, because you're going to need to know how to do it eventually anyway in this chapter. I just went ahead and showed it to you now so that we can get used to it. We will be writing in set builder notation in this chapter in the notes, so you might as well just go ahead and do it. You're not going to get it wrong if you do it on the homework, so just get the extra practice and do it on the homework. All right, the hard drive on your computer has a capacity of 120 gigabytes. Is that a lot? That's a lot? I suppose it depends on the computer. How much memory does your phone have? More than that. So that's actually not a lot these days for a computer. It used to be that 120 gigabytes, people would have been like, what are you talking about? 120 gigabytes? I don't even know what that is. Back in the day, not too long ago, 10 years ago, 20 years ago maybe, and we didn't even have gigabytes on our computers at all. It was totally unheard of to even have 1 gigabyte on something. And now we're talking about, so like 5 years ago, it was unheard of to have a terabyte. You guys know what a terabyte is? Okay, so that's what's like the new thing now, is everybody's getting like 1 terabyte, 2 terabytes on their computers. It used to be that to have a terabyte on a computer, it would be like the size of your car. Now they're putting it in laptops. So it's crazy how advanced we've become. Anyway, 120 gigabytes these days for a personal computer, like a desktop computer, is very, very small. You've used 85 gigabytes. You want to save some, I've used 85 gigabytes today, actually. You want to save some home videos to your hard drive. What are the possible sizes of home video collection you can save? Well, I'm kind of limited here by the amount of memory I have on my computer. I can't go over 120 gigabytes, right? Can I go exactly up to 120 gigabytes? Yeah. So, but I can't go over 120. So if I write down 120, I can't go over, but I can go up to 120. So that's going to be that. Less than or equal to. However much memory I use has to be less than or exactly equal to 120 gigabytes. Now, I've used 85. So I have 85 already sitting there that I've used. I have a bunch of home videos that I want to save to my hard drive. So I need a variable for that, because I don't know how much it's going to be. How about H for home videos? Or V for videos? H equals home videos. You always want to define a variable. I actually write it down so that you know. So I have 85 used already, and then I'm going to save a bunch of home videos to it, which means I'm going to add memory or add files that take up more space. So plus H. So whatever I had used before, plus that new home video or home videos that I put on there, has to wind up being less than 120 gigabytes. Okay? Now we're able to solve this problem. We just want to solve for H, so we're going to what? Yeah, just subtract 85 from both sides. And we get H is less than or equal to 120 minus 85. 35. So H has to be less than or equal to 35 mice. Gigabytes. Whatever that video is, it's got to be taking up less than 35 gigabytes. Is that a pretty long video? Can be, yeah. So there's your answer. So we can put that in set builder notation if we wanted to. This is a story problem, so we probably should just write a little something that says home video needs to be under 35 gigabytes. That's a really nice answer for a story problem. Remember, your story problem, you have units. You want to try to explain the answer in the context of the problem, and that does that. So if we want to graph that, just a number line, put our 35 here. Maybe I put 30 over here and 40 over here. For some reason that makes sense to me right now. Doesn't matter. Less than or equal to says a solid dot, and this way. Here's a question for you though. Can I have any number less than 35? The answer is no. Why? You can't go negative, that's right. So eventually down here I would get to 0. Like if I extended that out, I'd get to 0. And then that arrow would have to stop because I can't have anything beyond that. Okay? So this arrow would kind of come out to here, and that would kind of come back in, and it'd have another solid dot right there. And we're going to get to graphs that look like this later on in this chapter. But that just kind of extends the problem a little bit, gets you thinking a little bit more about what we're dealing with. All right, last problem. A club has a goal to sell at least 25 plants. Well, I don't have to read any farther, and I see this phrase right here, at least 25 plants. I'm already talking about some sort of inequality, okay? Club members sell 8 plants on Wednesday and 9 plants on Thursday. What are the possible numbers of plants that the club can sell on Friday to meet their goal? They want to sell how many plants?
At least 25.
At least 25. How many plants have they sold so far? 17. So to answer this problem without even really doing any math, how many plants do they have to sell on Friday? 8 meets their goal. If they want to exceed their goal, they can sell more than 8. 8, 9, 10, 11, okay? So to answer this problem without even writing anything down, that's the answer. 8 what? Fish? Plants. If we're going to set up an inequality, though, which is what this problem is trying to get you to do, then we want to sell at least 25 plants. So I have 25 sitting here. I want to sell at least, which means more than 25. I can sell exactly 25 because it's at least, kind of like 20 push-ups. If I tell you to do at least 20 push-ups, you're going to do 20 probably. So that's what we're looking at. On Wednesday we sold 8. On Thursday we sold 9. On Friday we sold, I don't know. There's your inequality. 8 plus 9 is 17. That's called combining like terms, which we can still do with inequalities. Plus x is greater than or equal to 25. Subtract 17 from both sides. This is the math that you did in your head. It didn't seem like it when you did it, but you did this math in your head. We get x is greater than or equal to 8. You want to put that in set builder notation, dress it up for prom? Fine. There you go. Now you got your nice prom dress on. Sparkly shoes, straps. What? Want to draw a graph? 8, 7, 9. Closed dot, greater than is to the right. You want to write your answer in terms of the problem? Need to sell at least 8 plants Friday. There you go. Okay? Lots of different ways to write the answer, but we could do the math in our head on this problem, which is nice. This is the math that you did in your head. Okay, so part B, reasoning. Can you use the same inequality symbol to represent these phrases? At least, no less than, greater than or equal to. Think about that for a second. Do those all mean the same thing? Let's go back to the push-up thing. If I tell you to do at least 20 push-ups, how many are you going to do? 20 or more. If I tell you to do no less than 20 push-ups, how many are you going to do? 20 or more. If I tell you to do greater than or equal to 20 push-ups, how many are you going to do? 20 or more. So the answer here is yes, these are all the same, okay? The explanation, since it says explain, you guys should be getting used to that by now. It says explain a lot, like on quizzes and tests, and you have to explain or you lose points. You would have to explain that kind of like I just did when I said, let's use the push-ups example. Okay? That would be a valid explanation. We did that verbally. This would ask you to write something down. Okay? So take a couple of seconds, write down what I just told you with that push-up thing. Think the push-up problem or whatever it is that you got to do, so that when you look back in your notes and you see that sitting there, you remember what it was that we talked about, so that you can answer that question if it were to come up on a test. Okay? After that, that is it for the section. You can do this entire homework assignment. Go ahead.